Welcome to another presentation on electromagnetic waves. In fact, it is EM waves. Electromagnetic waves are nothing but these are the waves which consist both electric field as well as magnetic field. So this electromagnetic waves consists of electric fields and then plus magnetic fields, right? So magnetic fields, so right, so combination of these two are called as electromagnetic waves, right? In general, the electromagnetic waves are cannot be seen, right? These waves are cannot be seen with our physical eyes, even they cannot be sensed also. Even the EM waves cannot be sensed, but these electromagnetic waves are exist in free space with a infinite distance, right? That is what the very important property of an electromagnetic waves. And one more important point is that the electric field as well as magnetic field both are perpendicular to each other. Both are perpendicular to each other means that both are exist with an angle of 90 degrees to each other. Okay, so say for example, I will explain you that. Say for example, so if you draw some wave like this to describe this electromagnetic waves, something. Say for example, if the electric field represented in this arrow mark, let us say for your understanding I'm explaining, then exactly, let us say like this, then exactly with 90 degrees the magnetic field will be there. Means that if you draw the angle, if you can put an angle between these two, let us say this is electric field upward arrow mark and the downward is with magnetic field H, right? And the angle between these two is exactly 90 degrees, right? 90 degrees. In that way, these two fields, electric field, in general, the electric fields are denoted with the letter capital E and the magnetic field is denoted by the letter H, right? The electric field, the strength of the electric field is denoted by the letter E and the strength of magnetic field is denoted by the letter H. Remember that both will exist to each other with an angle of 90 degrees, means that both are perpendicular to each other, that is what the very important property of these two, electric field as well as magnetic field, right? So far, if you can recall in our previous presentation, that in the beginning presentations of our videos, if you can see there, we have seen the different equations, electromagnetic wave equations. We have seen, basically we have seen four equations. Those are the Maxwell's equations, right? So what are those actually? The first law is an Ampere's law, the second one is the Faraday's law, right? The first one is the Ampere's law. Okay, the first one is the Ampere's law. What is the second one? Second one is the Faraday's law, right? The second one is the Faraday's law, and the third one is the Gauss law, is it not? It is Gauss law for electricity or for electric field, you can say. This is for electric field, and as well as the fourth one you can call it as same Gauss law for magnetic field, right? I will explain you a little bit now. Gauss law for magnetic field, right? Gauss law for magnetic field, and this can also be called as non-existence of monopole. The last one, Gauss law for magnetic field, is also called as non-existence of monopole. I will explain. I already explained in our earlier presentations, but again I will. Collectively, these four equations are called as our Maxwell's equation. What? Collectively, these four are called as Maxwell's equations. Right? So this is very, very important topic as far as your academic is concerned. Therefore, so the Maxwell's equations are nothing but these equations consists of basically four different equations. Collectively those four, what are those four? From Ampere's law there is a equation, from Faraday's law there is another equation for this, and Gauss law, that is third equation, and Gauss law for magnetic field. Let us see one by one these, and from this, so we can see, is there any expression for electromagnetic waves? So, is there any mathematical expression for electromagnetic waves? Yes, definitely there is certain expression for electromagnetic waves. So, for deriving the expression for electromagnetic waves, we have to refer again the Maxwell's equation, right? Let us consider the Maxwell's equation first. The first Maxwell's equation is nothing but in the point form. The Maxwell's equation in point form, or the Maxwell's equation in differential form, can be written as like this. It is del cross H is equal to conduction current density plus displacement current density. This is equation number 1, right? Del cross H. So it is what from the Ampere's law. This is the first equation, right? This is the first equation. Del cross H is equal to Jc plus Jd. This is conduction current density, displacement current density. And what is the second Maxwell's equation? You know, del cross E. Del cross E is equal to minus dou B by dou T. Dou B by dou T. That is the second Maxwell's equation. And what is the third one? Actually, this is from the Ampere's law. This is called as, this is Faraday's law. The first one is the Ampere's law. This is the Faraday's law. The second one is from Faraday's law. And the third one is the Gauss law. According to Gauss law, the dot product of electric flux density, this is the dot product, this is the curl actually. So the cross mark is called as curl. Therefore, del dot D is equal to rho suffix V, means it is volume charge density. Volume charge density, that is the equation number 3. And the fourth one is del dot B equal to 0, right? Del dot B equal to 0. Therefore, these are the 4 equations that everyone should remember, right? So this is your from Ampere's law. This is what from your Ampere's law, right? The second is called as Faraday's law. This is what from your Faraday's law, right? And the third one is the Gauss law for electric field. Gauss law for electric field means for E. And again this is the Gauss law for magnetic field H. Collectively, and remember that, so we are using the del means del cross H, del cross E, del dot D and del dot B. We are using the del operation here. What is del? You know, del is nothing but dou by dou T or dou by dou X, whatever it is. Okay, means it is differentiation. What I mean to say is it is a differentiation. That's why these equations are called as the Maxwell's equation in a differential form. In differential form, or otherwise called as point form, right? This is also called as point form. Okay, now, so these are the very important, and again here itself I will explain you some more important interrelation, I mean some identities which will be very useful while deriving the expression for electromagnetic waves, right? So if you can see this Jc, conduction current density, there is some equivalent expression for Jc, right? So otherwise I will explain you here itself, then you will be, it is good for you to understand actually, right? So from this just beside this equation I will explain you that what is Jc. Let us see here. This is the first expression, no? So this can also be written as, Jc is nothing but it is sigma times C plus Jd is nothing but dou D by dou T, right? So the conduction current density is equal to sigma times C. plus JD is nothing but displacement current density, that can also be given as dou D by dou T, right? Remember that. And further, this can be written as, this is equal to sigma E plus this can be written as D dot. Remember that. So this can also dou D by, that is the first derivative. Dou by dou T of D means it is dou by dou T nothing but first derivative. So first derivative of electric flux density. What is D? Electric flux density. So that is denoted by D dot. Right? Similarly, from the second equation, if you write, it is the first derivative of magnetic flux density. Therefore, this can be denoted as minus B over, you can represent with single dot like that. Means it is the dou by dou T of B. Okay, minus symbol is there, and this dou B by dou T can be denoted by B dot. B dot. Right? However, rho V equal to, these two are same. Right? These are the equivalent expressions. Remember that. Therefore, del cross H is equal to JC plus JD is the basic definition. And further, this JC can also be written as sigma times E plus JD, means J suffix D is nothing but dou D by dou T. Wherever dou D by dou T is there, then you can write as it is a first derivative. Therefore, first derivative of electric flux density D, therefore you can write D dot. Right? So, and the second is like this, del cross C is equal to minus B dot, and delta D, del of D is equal to rho V. It is a volume charge density, and this is del dot B equal to 0. These are the equivalent expressions. Now, I am going to explain what are the expressions of electromagnetic waves. The expression for electromagnetic waves can be defined in free space, even can be defined in a perfect conducting medium also. Right? So here there are two important cases. The first case is free space. What is a free space? Free space is a non-conducting medium. No charge. It is a chargeless. Even you can call it as a lossless medium. Free space is nothing but it is a chargeless, and it is a lossless, and it is a, okay, it is a okay. So that is what actually lossless medium, free space. Therefore, let us consider as a first case the free space medium. So in the free space, how the electromagnetic waves can be defined, that we can see now, and afterwards the same electromagnetic waves can be defined for perfect conducting medium also. Free space is a non-conducting medium. Remember that. Okay, free space is a non-conducting medium, right? Non-conducting. Therefore, the same expression can also be seen for conducting medium also, perfectly conducting medium. Now let us see the electromagnetic waves for free space. Okay, let us see the electromagnetic waves for free space. Okay, so let us see that. So for deriving the expression for free space, in free space, we have to remember that again you have to consider the first two Maxwell's equation. Those are del cross E is equal to, it is minus dou B by dou T. This can also be written as minus B dot. Let us consider this expression. Clear? And then del cross H also we need to use this also. It is minus, what is this? Sigma times E plus D dot. Can I write like this? D dot. Just now as I explained. And moreover, the identities whichever we use to, so we have to remember that B is equal to, what is the formula actually? B is equal to mu H. This is magnetic flux density is equal to permeability times the strength of the magnetic field. So for, okay, so this can be written as, it is mu naught into mu R into H. B is equal to, why? Because in fact mu is equal to mu naught into mu R. This is the definition for permeability, actual definition. Mu is equal to mu naught into mu R. So mu naught is the permeability of a free space, and mu R is the relative permittivity of free space. Okay, free space permittivity, and this is the relative permittivity of the medium. What is the medium in a free space? It is a air. Therefore, Is it not? The relative permittivity of air, the medium. What is the medium in free space? Air is the medium. Therefore, for air, mu r is equal to 1. Therefore, mu is equal to mu naught only in free space. In free space. Is it not? In free space. Therefore, in free space, your B can be written as B is equal to mu naught H. That's it. Remember that in free space, B is equal to mu naught H. Okay, this is the magnetic flux density to magnetic field strength. This is the relation. And similarly, you can write for, there is one more identity which normally frequently we can use is the electric flux density. What is the electric flux density? It is D. D is equal to epsilon times E. This is another identity normally which we can use. And what is epsilon? It is the permittivity. Permittivity is equal to, in general, the definition is epsilon naught into epsilon r. Remember that. This is another very, very important formula. Epsilon is the permittivity, that is equal to epsilon naught into epsilon r. What is epsilon naught? It is a free space permittivity. And what is this epsilon naught? It is the relative permittivity. Relative permittivity of the medium. So what is the medium in free space? Air is the medium. Okay, air. So for air, your epsilon r, again the value of epsilon r is also 1. Therefore, what is your epsilon? Epsilon is equal to epsilon naught itself when you consider the free space. Therefore, if you consider the free space, your epsilon becomes epsilon naught. Therefore, substitute this expression here. Then what is your D? D is equal to, it is epsilon naught into capital E. This is the D expression for free space. So, these are the very, very important relationships that we can consider, okay, while discussing about the free space. So, in free space, B is equal to mu naught into H and D is equal to epsilon naught E. Right? These are the very important equations that we have to remember while discussing about the free space. Right? Now let us see what are the expressions for electromagnetic waves in free space. For that, it is very easy. It is nothing difficult. It is very easy to define the expression or to derive the expression. Very simple actually. There is nothing. Let us consider del cross E. Let us consider del cross E actually. Let us consider this expression, call it as equation number 1. Is it not? So del cross E is equal to what I can write? B is equal to, actually what is the definition for B? B is equal to mu H, no? Therefore, what is B dot? Is equal to mu into H naught. Can I write like this? Therefore, here I can write mu times H naught. Can I write like this? Okay, del cross is equal to, minus is there, B is equal to mu H, as dot is nothing but first derivative of magnetic flux density. The same will apply to here also. Okay, B, okay, nothing but H dot. Is it not? And then next we can take the cross product on both sides. Let us take, this is second equation. Let us consider curl operation. What is that? Curl operation on both sides. So let us apply the curl operation. Nothing but what you know, del cross. This is curl operation. Del cross of del cross E. So for del cross E, you just apply del cross. This is what we are applying, curl operation on both sides. This is equal to, again apply here del cross of minus mu into H dot. Right? Then this becomes, so from an vector identity, from the definition of the vector identity, this del cross E can be written as del of del dot E minus del square E. You can refer your vector knowledge, vector basics, right? So del cross E, from the definition of vector identities, this can be written as like this, del of del dot E minus del square E. Okay, the left side part, this part can be written as like this. And similarly here, so it is mu, take outside, However, permeability is a constant, therefore you can write mu outside. It is del cross H dot, del cross H dot actually. Is it not? Is it not? So what is H naught actually? What is H naught? Del cross H naught. H is equal to, is there any formula for del cross H is equal to what? There is a formula, no? I will explain you that. What is the formula? I already explained in the beginning itself now. So I can write that here. So the continuation part of it is equal to, it is del dot E. It is del dot E minus del square E, right? This is equal to minus mu times del cross H. Clear? Clear? Del cross H. Clear? So I will erase this. It is not required now. So from here, okay. So what is del cross H actually? What we know? We know that del cross H is equal to what we know? It is JC plus JD, no? Basic definition. And this is equal to sigma E plus dou D by dou T. Is it not? Remember that for free space, we are doing everything, all these things for free space. For free space, remember it. So for free space, sigma equal to 0. Sigma is equal to 0. Remember that sigma is equal to 0. Therefore, put this here. Therefore, this becomes 0 actually for free space. Then this can be written as, what is JD by JD? This can be written as D dot, no? First derivative. Okay. And further, so this D, I know that D is equal to epsilon E, no? Substitute that here. Therefore, in place of, this is 0. In place of D, substitute epsilon into E. And this, obviously, this dot mark becomes here. That will come here. Therefore, epsilon times E. Is it not? What is del cross H is equal to? Del cross H is equal to. But what is there in the formula? Del cross H naught. Del cross H naught. Therefore, this means del cross H naught is nothing but, okay. So you have to, so first derivative. So first you have to consider H is equal to E dot. And if you take the H dot means, so epsilon, this becomes a double derivative. Because H is equal to first derivative of electric field. Now if you take the derivative again, this will becomes dou square by dou T square. Therefore double derivative epsilon E dot. Therefore, so you have to substitute this expression. I think you are getting this. Substitute this del cross H naught value, that is epsilon double dot here. Then if you substitute there, then obviously what you will get, you know, obviously what you will get. So this is for your reference, I explained here. Now I can write there this as, and also remember that this part, so it is del dot E actually, del dot E. Obviously if you refer that, this becomes 0 for free space. Why? Because, so again this will be from the definition of del dot D. Del dot D is equal to rho V actually. And again, what is D? D is equal to epsilon E is equal to rho V. And here epsilon is the take constant outside. Then it becomes del dot E. It is rho V. And from this del dot E is equal to, what is this? Rho V by epsilon. And for free space, remember that rho V equal to 0. For free space, remember that for free space, volume charge density is 0. Therefore, obviously del dot E also becomes 0. Therefore, this part becomes 0 for free space. From the definition of this, your del dot E also 0. Then what you will have, you know? So if you can write this as, right? So little bit you follow this and definitely will get the solution of it actually. So means that for free space this becomes 0. Then it is equal to minus del square E. This is equal to minus mu. Is it not? Then how this can be written as? It is epsilon E double dot. As I explained here, epsilon double dot. Therefore, both sides this implies, so means it is minus delta square E, this is equal to minus mu epsilon E double dot. Clear? Both side minus will be there, minus minus will be cancelled out. This is equal to del square of E is equal to mu naught. You can write mu naught. Actually, for free space, mu becomes mu naught, epsilon becomes epsilon naught, and your E is nothing but double dot. This is the wave equation, one of the wave equation. Delta square E is equal to mu naught epsilon naught into E dot. That is the wave equation. Clear? And so you can try for in the similar fashion. You can write for H also. Then you will get delta square H is equal to, same you can get that, mu naught epsilon naught, and it is definitely H double dot you will get normally. So here E is equal to E double naught. Therefore, if you write for the same for H, the magnetic field strength, H equal to, it becomes H double dot. This will be for magnetic field. So collectively these two expressions are called as electromagnetic waves for free space. So delta square E is equal to mu naught into epsilon naught into E double dot. Delta square H is equal to mu naught into epsilon naught into H double dot. So these are the expressions for electromagnetic waves in free space. I hope you understood well this, and we will finish off this presentation here, and we will see in our next subsequent presentation that the derivation or the expression for same electromagnetic waves for perfect conductor. In free space, only the thing is the conductivity becomes zero, sigma becomes zero, volume charge becomes zero, because no charges are available in free space. That is why the volume charge becomes zero. As per that, this product will become zero here. Therefore, you will get these expressions, right? So I have explained you one thing, and you may try for this expression on your own, right? Otherwise, in next presentation, I will explain this also, how this expression can be derived. Hope this will given good information to you all, and definitely request you all that if you understood this, and do not forget to share this information with your friends, and give your valuable suggestions and feedbacks, and any comments you can feel free to give us, so that it will be very useful for us to improve the content of this presentation, and thereby most of the students can be benefited the maximum, right? So let us meet in our next presentation. Till then, have a wonderful day.